All righty, morning everybody. We're gonna wait a couple more minutes before starting, just to give everybody a chance to get into the meeting. That being said, you probably know what I'm gonna say already. Let's start seeing some videos turn on. Love to see you guys. Let's go ahead and get that going. It'll take you a second to put pants on or something. All right, well, let's get moving. Morning, guys. I'm Jack. I'm about half of your TA. Put the plural wrong in that sentence somewhere, but Jasmine will be the TA for about half of you. That being said, for the time we're online, one or the other of us will take this 9 a.m. class. So you might see me probably most weeks. Otherwise, it'll be Jasmine. I'll probably just end up taking hers from her. That being said, hopefully we're in person soon and I won't see half of you. I'd love to not see half of you, but that's due to no fault of your own. I guess we'll just start by hitting some basic introductory stuff. This is the recitation for 3155. I don't know how you would have gotten in here if you weren't in that class. This is the 9 a.m. Friday recitation. There's bunch of recitations all day. If for whatever reason this is a weird time for you, there are probably other options. My name is Jack. I'm a third-year PhD, I think a third-year PhD student. With COVID, who knows how to count anymore. My email's there. You probably don't ever need to email me. Most of our communication is going to be through Piazza. That'll allow you to just get a quicker response. I don't check my email all that often. It's the only way a grad student has control over their sanity. So post on Piazza first. If it's something of a personal nature, so accommodation letters, death in the family type stuff, personal situations, that's okay to email me. I'll usually get a response back pretty quick. I do see my email, I just don't often respond. And if I don't respond for whatever reason, feel free to just spam me, like send me a couple emails. That bumps you up on the urgency list. So yeah, but don't email me with code or homework or stuff like that. That's really for Piazza. I'm sure Sharon gave you that spiel the other day. For half of you, Jasmine's your TA, so email her. Don't email me. Even for these first couple weeks, if you have something of a personal nature, accommodations letters, stuff like that, email her. She'll take care of that stuff for you. There's other stuff I wanted to hit. I'm a grad student in the CU PLB lab. You guys will be studying programming languages this semester. That's the lab that studies programming languages and verification. So you got an expert teaching you, or I'd like to think I am. I've taught this class. I've been Shri Ram for this class. I've been the primary instructor for this class twice. One of those was a big lecture, 200 seats or whatever. And I've been a TA for this class 2 or 3 times now. So I've also taught discrete math in the past, if any of you have taken that. Yeah, so you guys got the experience TA this semester, good for you. I can't think of much else. Went to Mizzou for undergrad, studied computer science. Now I'm doing the grad school thing. As far as course logistics go, we'll meet here every Friday, this Zoom class until university opens back up. basically every week we'll be going over some kind of Jupyter notebook with Scala code in it. Just basically exercises, getting a little bit more in the weeds into what Shriram goes over during the week. So that's kind of what we'll do every week. I will mostly be working on my iPad and writing along. I'll have the code alongside. It just lets me kind of notate stuff a little easier. And you guys can type along in Jupyter. If for whatever reason I need to pop into Jupyter, I can do that pretty easy, but I'm hoping not to have to do that. So yeah, if any of you had trouble getting your Jupyter notebook set up, I believe there's a virtual machine again this year. Reach out to the CAs. They're going to be the ones to help you with that kind of stuff. I don't know how to even fix Jupyter. I set it up 3 years ago and haven't touched it since. So reach out to them. They'll be able to get you hooked up real fast. If there are kind of problems getting that all set up, reach out to me and we can figure something out. But yeah, so I'd say just have that week 1 notebook that got sent out properly, hopefully. Maybe someone shake their head, nod their head. Yeah, okay, I got a thumbs up. I like it. Yeah, so have that open. We'll go through those examples. Other than that, I'm pretty sure we do our spot quizzes, whatever Shriram's calling them now. In Recitation, that could change. I have no idea. But otherwise, I think that's everything logistically I wanted to hit. If you see me looking up like this, I'm looking at my computer screen. I'm not staring off into the distance and ignoring you guys, I promise. Any questions before we get started? Thoughts, concerns? What you had for breakfast this morning? Anything's fair game. Oh, so some questions in chat. Is the notebook the one called Basic or Basic Introduction to Scala? I don't think so. It should be called week 1. And I can actually, give me a second. I'll pull a link to that real quick for you guys and we can jump into this. If you don't have the notebook pulled up this week, that won't be a huge, huge deal. I should be mostly laying everything out as we go on my iPad. Let's see. I had a lot of problems trying to find out where these were earlier too. Week 1 recitation. So I just threw a link to that in chat. If you don't have it yet, I hope that's the right one. If not, we'll see how this goes. So, okay, so let's jump right into it. Can anyone remind me what you guys went over your first couple lectures with Shriram? Just a quick high level, what kind of topics were you hitting?
It was mostly just a review of Pascal, or no, sorry, not Pascal, Scala. I get those mixed up.
I was gonna say, hopefully Scala. But yeah, right. Were you saying Pascal or Haskell?
It's the one that makes less sense.
The one with an H, Haskell. A lot of people say that name wrong. That's a language. I do most of my research in Haskell. So yeah, you guys will actually learn mostly. I'll probably kind of bleed notation a little bit. So you guys will probably get a little Haskell primer as we go at some point. But even learning in Scala, you guys are going to be able to read that kind of language really fast. So yeah, a benefit of this class is you guys will start picking up on just how languages are structured. And you'll be able to pick up a programming language in minutes, really, hopefully, when we get really moving with this. So, well, cool. So just kind of an introduction to Scala stuff. That's what I've got here. So I think the first exercise Shriram wants us to work over is how to kind of remove these return statements. So a pattern we'll see throughout the semesters, we're going to move away from what we'll call these kind of control flow based programs where we have statements and conditionals and loops, and we'll move more towards what we call a functional style of programming. And Scala is really good at writing this functional style. Other languages like this are Haskell, Lisp, there's a bunch of others. We in the PL community really like them because they're really cool. They're very structured. We like how they, a lot of their properties are just really easy to play with. So we'll kind of move from the statement-based version of programming to this functional-based way of programming, and we'll start there by kind of learning how to remove these return statements in these functions. So we just have a basic function here called foo. Draw your attention to, I don't know, can you guys see this laser pointer okay? In the red? Yeah, cool. I'll use that. I haven't ever used that. It hasn't popped up before on the iPad before. So yeah, so this foo function is the first one we'll take a look at. Take a second to read it. Pretty basic function. I don't think it does anything super interesting, but we're taking a look at it. Our goal is we want to write this program without using the return keyword at all. Okay, so take a second to try and play around with that. Play around with that in your notebooks. You're going to try and fill in these question marks in this foo2. So you're trying to fill in foo2 where the question marks are. So take a stab at that, and we'll talk about how to do it in a second. I'll give you 2 or 3 minutes. It shouldn't really take you too long. I'll give you a hint here in a minute as well. So I just threw a hint in there, filled in that first question mark for you. Try and see if you can do the other 2. Should be fairly straightforward. Righty, anyone want to take a stab at filling in these last 2?
Is the first one just x minus y and the second one just x plus y?
Right on. So x minus y for that first one, and else is just x plus y. Thanks, Chase. Now, why can we do that? Why don't we need the return statements here anymore? What lets us just fill these in like that, just putting a result as opposed to kind of saying return a result? Does anyone have an intuition or an idea as to why that is? Forgot to mention, we'll be doing a lot of back and forth in my recitation, so get that microphone warmed up. I won't be just giving you answers for the next 16 weeks.
Is it just a syntax thing? Like with C, if there's only one line, you can just leave no curly braces?
It's similar. It is sort of just a syntax thing, but it's actually a little bit more nuanced. So what we do here is, I'm going to actually draw this out. So if we look at this function up here, and this is a way we're going to start looking at functions awfully quick, is here I have kind of this if. We can think of kind of constructing a tree with this program. So we have an if statement up top. That if statement has some condition on it, right? So it's x equals 0. If x equals 0, then we have a return. 1, right? We can look at this program as that, or at least this first line, this 2. And then let's say if this program doesn't kind of get a hit, we move to the next one. So for our next line, we'd have something like another if, and the condition here is going to be x is greater than or equal to 0, and y is less than 0. If that's the case, then we have another node down here. It says return, and that return will have kind of another node where we do minus, and minus has an x and a y. And then we could also do the last one, which is just the third one's just a return plus with an x and a y. So we can look at these as kind of these tree structures. And on a given line, if we don't kind of hit the conditional, we control flow out of it. So we'll try that first if, then we'll try the second if, and worst case, we return x plus y. The other thing we can do is we can try and write this all as a single tree in the same form like this, or a very similar form like this. And this is what this looked like. So in our second example, foo2, what we're essentially doing is, there we go, got my circles working again. We have an if statement up at the top. If x equals 0, and then what we'll do is we'll have kind of two different branches. So this will be the then branch, and we'll have an else branch. Okay, so this is what we're dealing with here. And then in the then branch, we have then, we just have a 1, okay? 1 is just, we can think of this as the result of the computation. We don't return anything. It's just when we have x equals 0, the answer is 1. You can think of it like that. It's not returning a result. It's asserting some kind of value. So we have 1 there. And then in the else case, we have another circle. Here we have another if block. Okay, that if block's got to have a condition on it. So what's our condition here? X is greater than or equal to 0, and y is less than 0. Okay, same thing here. We're going to have a then case. That then case says we have a minus applied to x and y. And then on the else side, we have a plus x and y. Okay, so you see how we collapse that all into a single tree as opposed to moving line by line, which is what we did in the first function. We have a single expression is what these are called. So here we have a single expression. And up here we have multiple statements. Now, Shriram later will get into what the technical difference is there. For now, I just wanted to start by introducing that a little bit. Is what we're moving towards is more of this, let's construct a single tree as our program as opposed to these separate things there. Any questions so far with what I just covered? Is that super confusing probably? Thoughts, anything? So, okay, so I just noticed there are a bunch of questions. So do we need curly braces? You should not, no, I don't think. Let me try real quick though, just to be sure. But you should not need curly braces. confirmed. You do not need curly braces. You can leave those out. Everything is an object. So Charles, we'll get to that a little bit later. Everything in Scala is an object, but the idea of an object is going to break down a little bit as we go. Object that's kind of becomes a technical kind of implementation level thing at a certain point with the language. So let's think of everything here as an expression in the second one, and we can think of statements up above. So I believe if in the first program, you should be able to put semicolons. Yeah, you can put a semicolon after return 1, return x minus y, and return x plus y, and it would work. That's actually probably almost a better way of writing that because it makes it really explicit that those are statements. If you tried to put a semicolon anywhere in the second version that we wrote, you wouldn't be able to. It'd freak out at you. Because semicolons kind of go along with it being statement-based programming. So, and then lastly, so it's somewhat like the ternary operator in other languages. So yes, exactly. It's just like the ternary operator in other languages. Or rather, the ternary operator in other languages is like this. So we're trying to construct a single line, you could think, as we want to collapse it all into a single line. Anything else? I'm super okay with people asking questions in chat too. Prefer you to just ask, but either one's fine, whatever you're feeling better. Okay, and so lastly, let's take a look at this foo3 program. What's going on here? So you could also put curly braces around everything. That works. Keyword. So this is going to be derived from the same original foo function with curly braces around it. The curly braces essentially mean return in this case, or it says kind of return this curly braced program. I'm not exactly sure why this example is in here. I don't think it shows much, but if Shiram talked about this particular sort of example, interrupt me and tell me why.
I think it's supposed to say without else and not without return.
Without else. Oh, that makes more sense. Else if, yeah. Oh, because this is the ternary version of writing the same thing. Because you could collapse that all into a single line, I bet. Maybe not. You can't, but it's probably to show off that it can be written in a ternary fashion as well. I'm sure if I put curly braces around the if. So that's probably what that's trying to point out. Otherwise, we'll just move on to the next example. So this example has a little bit more going on with it. So this time we have, we're checking if x is less than 0, or yeah, less than 0, and returning 20 if it is. Then we construct this value y. We check something about y and return 45, or we return y. So same thing. I'll give you a quick second to kind of work on this and try and figure out what should go in the question marks down below. We've restructured the program again. Figure out what should go in these blank spots for me. Anybody got an answer for me?
Yeah, just same as before, just get rid of all the return statements and just leave the values.
Right, so let's just leave the values and remove the returns. We got 20 there. we have val y, and here we've got x plus, or x times rather, x plus x. Not really sure why that was question marked out. Or I guess minus, not plus. And then our last two are return 45, else return y. Did I get that right? So that's how we're going to do that one. I think this example is trying to show off what val does. So this val statement, did Shriram talk about these in class the other day?
Yeah, we did.
Okay. So just as a reminder for
We kind
y'all.
of talked.
Yeah, so vals are immutable. So once you set them, you can't change them again. And a var is the other version. You'll almost never use a var in this class, are mutable. Another word for mutable is stateful. And those are like your variables that you're used to in, say, a C or a Python. You can change them however you want. Vals, you're not allowed to change. They're just kind of handy. I'm giving a name to something because I need to reuse it a lot. It's really just kind of a convenience thing. Whereas vars, you can actually change over time, and that actually has a different behavior. We'll see later on that these actually have a really, really huge difference in effect the way you write programs. Anything else to point out with this example? I don't think so. We like giving types to everything. So even with this val, we give it type int. We don't necessarily have to put that there, but it's super useful too. Now, what happens if we just remove return from this function? This is the other case. So in bar 3, all we've done is removed the return keyword. We haven't changed kind of how our ifs are structures. What happens in this program?
Someone in chat said it would always return y. That sounds best.
Yeah, it always returns y. Why does it always return y?
Because y is the last statement in the function.
Right, so it's going to ignore everything else above it for the most part. Here we're not constructing a larger if statement. So this if statement on, say, this line is really an if expression. It's separated by the lines, but what it's saying is I'm constructing you a value that if x is less than or equal to 0, I'll give you 20. That's its own thing. The rest only comes into play, that will never come into play. Y is the only thing that matters here. The only other stuff that's going to come into play is if it refers to that y. So here we don't, so we just kind of end up having whatever y is. So it's not quite the identity function, but it's something pretty darn close. So it's just doing this kind of, this middle line here. So be careful with how you use return statements. When in doubt, always just do an if else, if then else, written out the whole way. That's going to be your best friend. I believe there is a ternary operator in Scala. You can look up what that is. Feel free to use it. If you want to save the space, I don't know as though it does save you much space, but completely up to you. Just make sure it works right. That's kind of the general rule in this class. Make sure it works. Okay, let's move on to example 3 now. So this one is highlighting something very particular this time around. It's a similar critique. So we'll notice that if you were to run, and in your notebooks, you should actually have the error that if we ran this program or tried to compile it, we would get something called a type mismatch. And you guys will see a lot of type mismatches this semester, and you've probably already seen them a bunch of times in your programming life. What is a type mismatch? Somebody give me a definition or just a guess at what that means.
Is it just what it sounds like, just when you have the wrong type assigned to a variable, or returning the wrong type, probably?
Right on. So it's kind of when I say, so in this case, I have, there's something nuanced here, but I say, for instance, like X is of type int, and then let's say it's a var, right? So var X, so I can assign it. And then I say X is equal to true. On its own, that would give a type mismatch because true isn't a number. We could write this true is not in int, or true is not of type int. That's not really a symbol we ever write, but now of course we can cast true into the integers, but on its own it's not really an int. So this is an example of a type mismatch, but why the heck do we have one here? Because I don't see anything but integers in this program up above. So if you guys look, it says in the error, it says type mismatch. And it says found unit and required int. So what the heck is unit? Does anyone know what that is? I haven't heard of the unit type. What's the unit type?
Isn't it the generic type like void?
Is it void? That's an interesting question. So what's the void type? Do you guys remember what that is?
Some pointer thing in C, like a null pointer?
So it's not that. That's actually a different idea, right? Because that's null. Void is, it's typically, Java uses it a lot. Void is the idea of a function that doesn't return anything, right? And I believe, I'm checking real quick. I believe void is the unit type. Yes, so it's roughly equivalent. So void is approximately the same as unit. So this is the type of, when it's kind of the return part of a function, it's functions that don't return anything. And that's when the functions of this form, right? So if I have some type A to void, those are functions that don't return anything, right? So I'll use arrow to denote function types. So up here we'll have simple fun. This is what we'd call an int arrow int function, takes an int and returns an int. You'll see this notation a ton. Shreyam will introduce it at some point. You guys get it early with me because it's super useful. So if the unit type is the function, it's type functions return anything. Unit type is more particularly, I'll give it a proper definition. Unit type is the type or set, right? Because we can think of types as sets, as we would have learned in discrete math, with exactly one inhabitant. And this will be usually called, sometimes it will be called unit of type unit, like so. That being said, you don't necessarily need to know that. All we know is as placeholder for functions when kind of nothing else is specified. So yeah, so Ryan asks, so how is this function not returning any of the values 10, 20, or 30, right? Which is the central question. Why is it returning unit? Does anyone have any idea as to why that is? Because I haven't answered that yet, right? We just kind of went into a foray on what the unit actually is.
Is it because you're not using an else statement? So it doesn't know it's going to reach the return values?
Right, you're 90% of the way there. So I'm not using else statements, right? So I have this kind of, this essentially a statement-based view of the world, right? I'm not constructing a single expression. So what happens if I get to line 4 and I don't match any of the ifs? What happens? Every function has to.
I was going to say you're using because you don't have semicolons at the end of your return. Return should be an expression.
Do you need to catch when it doesn't hit any of these?
Yes. So if it doesn't hit any of them, what happens?
Well, then you get the void return. So you need an else to fix that.
Yeah, but like what would happen if, let's imagine a world where I did run this, right? And pretend in this case, obviously we do hit every case, so we never hit the else, but pretend we did. What happens? What do we return?
Say that again.
So let's say I run through line 2. I have some x is less than 0. Okay, let's say my x is bigger than 0. So okay. I move on to the next case. Okay, line 3. X is less than 10. Let's say my x isn't less than 10. Okay, what happens? Well, I move on to the next case, right? X is greater than 10. Let's say my x isn't greater than 10.
Well, how can it be less than or equal to 10 and not be greater than 10?
Right, we're going to pretend that, so let's say somewhere in between those lines I changed my x, for instance, right? Let's imagine a world where this, so just for argument's sake, because this does happen, just not with the numbers. So Shriram gave us a fun example. What happens when I go down to the next line?
It would automatically return nothing.
Nothing, right? But we can't return nothing per se, because remember, whatever's on the last line of the function, that's what's getting returned. So if I return if x is greater than 10, return 30, right? If that's what's getting returned, but I don't match the 10, I have to spit out something. We always assume that if nothing else is specified, we get the unit. It's just a convention of the program. When nothing else is there, we return unit. Now, this makes sense. If you think about if you had a program that mutates state, you don't always really need a return statement. You could have a void and you don't need to put a return in a void function. That's essentially what's happening here, right? And when that happens, we now have, it gets a void, our unit, right? But it's expecting an integer. So what do we do to fix this? We write out our entire if then else kind of block, right? So here we do x is less than or equal to 0 and x is less than or equal to 10. And then we're good because that covers all the cases. We can just ignore that last conditional up here. Questions, thoughts, concerns, ideas?
If you put a semicolon at the end of the returns, would it fix the compiler?
It would not, because you could still, on the last line of the program, there'd still be a void that's kind of inserted there without us really kind of caring about it. So it's not just the semicolons. These are already statements with or without the semicolons. Semicolons are usually just left out as a convention. They don't actually necessarily do anything. Sometimes you put them in there just to be deliberate, but here they're there. We can pretend they're there, I guess. Now, Ryan, I'm glad you pointed out that here we hit every case up above, so we don't need to really worry. we'll see soon, and then I believe Shahram will introduce this syntax, I think, next week, where we can make that assumption. Right? We'll see these will be called case statements, and we'll use them all the time. We really like case statements, so we'll introduce those real soon. We're hitting up on time, so I'm going to really rush through this last section. So recursion is the next part that we're going to cover. Let's see what notes we had with collapse conjecture. So consider the following function. The following function is f of x is equal to, and then we define it piecewise, x divided by 2, or 3x plus 1, if x is divisible by 2. I'll write this in the more discrete notation. So 2 divides x, and this in the else case. So it says that basically the Colas conjecture says that whenever we apply this function repeatedly, we'll eventually get 1. The result will always be 1 if we apply f of x over and over again. We want to test this, so we can test this using a while loop. And that's what this function is, right? So we say n is equal to x. We have 2 mod, or n mod 2 equals 0, right? That's essentially this part. Then we divide it by 2, right? That's here. Or we do this part, right? Just the else. So we're testing it, right? Run that, and every time it should give you 1, right? If you played with this in your Scala notebook, it would give you 1 every time. Now, how can we write this recursively? So if we want to remove this while loop, what are we going to do? How can we do that? So I'll just kind of walk us through it since we don't have a ton of time today left over. We can do this with, so we have def test collats rec. We have x of type integer as input, and our output is also of type int. That equals, and we open curly brace. Okay, now how do we write this? So we have a few cases here, right? We have this n up top that we use as an iterator. We won't need that this time. And then we have a while loop. So basically, the while loop's we're gonna consider 2 cases here. One in which n is equal to 1, one in which it's not. So we'll do an if n is not equal to 1, then we'll have a then block. So we'll have the inner block. I'll use curly braces this time just for make it all clean. And then we do if n div 2 equals 0. Then we are going to do the recursive call test collats rec of n divided by 2, else we're going to do the recursive call again, test collats rec of 3 times, I guess not n, it should be x, so pretend that this is x, not n, or n, not x, rather. 3 times n plus 1, and then we'll close that brace from before, and then we need an else statement to close down everything. Else, which means x is equal to 1, we'll just spit out n as the result. Okay, so now I've removed that while loop. Does this work? Hopefully someone was typing it in as it was writing. Does that always give us 1? I hope so. I hope I wrote that right. The idea is that anytime we have a while loop, and we're kind of using an iterator, our iterator here is n up here, we're able to replace that iterator with an argument to the recursive function, and just feed in the result, the return statement, or whatever the updated iteration is, into that function. So that's essentially what I'm doing here is instead of writing n equals n divided by 2, I'm feeding it back into the function n divided by 2, and then I'm checking for our while condition. I'm checking for its termination basically at every step. Any questions on how I did that? Obviously I had to kind of rush through it. Nothing, all looking good. Cool. So our last example, I'm gonna actually kind of leave for you guys and we'll make sure the result gets on Canvas, but I'll walk us through what we need to do here. So this is a class with a few operators in it. The thing that we really want you to learn here, because you all know what a class is, so we're not gonna really go over that too much. What we want you to do here is we remove fish, and in this first program, we'd like you to basically remove some n number of fish from a body of water. That's pretty straightforward. And then here, we're using an operator, and these operators, it's basically anything symbolic, so anything that's not alphanumeric. You're able to write something like, basically it's a class operator. So we say, okay, give it some body of water, and then we can use something like the fish operator with, it takes a number as an argument. And we can use it in line. So instead of doing kind of the normal fish operator with parens and then giving it body and 5, you can write it like this in line. That's essentially what we want you to learn here. Try it out, try writing these functions. Like I said, the results will get posted on Canvas pretty quick, probably by the end of the day, I'd imagine. So just try that one out. I don't think we need to walk through it. It's not something we'll actually use a whole lot in class. It's just kind of a neat little feature that we like to go over. So we're just about at time. So any questions before we part? Anything kind of along those lines? Cool. Well, have a great week, guys. If you have any questions, I'll hang out for a few more minutes. Or actually, I'll be hanging out for the next hour because I have another recitation in 10 minutes. So if you have questions, I'll be around for the next 10, 15 minutes. Otherwise, have a great week. And I'll see y'all next Friday.
I have a bit of a logistical question for you if you have time.
Shoot, I got plenty.
This is the in-person recitation, right? In the fall?
Yes.
Or sorry, in
the spring, yeah.
Coming
this
month?
Spring, yeah, next month, hopefully.
Yeah. This is my only in-person class, and I think you have to do a bunch of stuff if you have even one, like a health questionnaire and stuff.
Okay.
Is there like any way to not be in person to get out of doing all that stuff?
Yeah, there will be. So I don't know what that looks like yet. I'll have to ask, but when that comes time, chat with me and we'll work it out. Because there are some online sections. That's why the class was 20 people today instead of just 10. One of those sections is online. So worst case, we just move you over. That shouldn't be a big deal. Otherwise, I'm pretty sure we won't. We probably, I don't know. I don't know if we'll end up actually ever meeting in class. So I just say, hang on, wait till the university tells us stuff. We haven't been told how that'll all work yet.
Cool. That was a good first recitation. Thank you.
Well, cool. Thank you. Have a good week.
You too. Bye.